Welcome to BC Housing's Building Knowledge. This session introduces the concept of a digital data-driven process, commonly known as BIM, before moving on to discuss this process from the perspective of the capital planning and then the facility management teams. First, a little bit about me. I'm an architect, registered in both the UK and here in Canada, BC, with over 30 years of experience in the AEC industry. I frequently present at conferences and serve on the Building Domain Steering Committee of Building Smart International and the Asset Management and Lifecycle think tank for building transformations in Canada. As a BIM consulting service provider, Summit BIM specializes in helping owner-operators to realize the value of their building data. We help owners define their data requirements, project manage the data, conduct audits to ensure that standards are being met, and that the data can support the downstream uses defined by capital stakeholders and required by maintenance and operations throughout the life cycle of the facilities. First, BIM 101. There is huge confusion around what BIM is, and the internet is not helping. BIM has about as much definition as the term building, and associated with the confusion is what is known as BIM wash. BIM wash or BIM washing is a term describing the inflated and/or deceptive claim of using or delivering building information modeling services or products, also termed faking the BIM, where what is typically described are simply the tools that enable the BIM process to occur. BIM is not 3D. BIM is not Revit, and BIM is not drawings, nor is BIM CAD. BIM uses digital information, data, to undertake design and construction, as well as to provide information for facility management throughout the life cycle of the built environment, for both vertical and horizontal infrastructure. BIM is a digital, data-driven process, not software. It is comprised of policy, process, technology, and people. It is about building a digital data set of the facility that other software solutions can utilize. ISO 19650 provides a framework for managing and defining this process. Why change from CAD to this digital process? It improves efficiency. It enables real-time sharing and updating of project information, fostering better communication and coordination. It reduces errors. BIM helps identify clashes, conflicts and data inconsistencies early in the design phase, which minimizes errors, reduces costly rework, and enhances project quality. It provides accurate data, precise information on project components, materials, and performance allows stakeholders to evaluate different design options, assess feasibility, and make data-driven decisions. It provides spatial awareness by creating a virtual representation of the building project. BIM enables the identification of spatial conflicts between different building systems, such as structural elements and mechanical ducts. Clash detection or virtual coordination helps avoid costly rework and delays during construction. It also provides accountability. BIM promotes accountability by clearly defining the owner's goals and defining strategies, roles, and responsibilities for each project stakeholder. BIM is an auditable process, which enables team members to check whether issues have been resolved during design, construction, and prior to handover. And one version of the truth. BIM ensures data consistency across the project lifecycle, reducing the risk of conflicting or outdated information. This promotes accurate decision-making and collaboration. This data-driven digital process enables better management of risks associated with design and construction, supports the ability to undertake virtual coordination, supports faster and more accurate estimating, supports prefabrication, assuring consistency. It enables data reuse, reducing waste, and it supports on-time and on-budget delivery of the project. This digital, data-driven process is enabled by the use of data-driven software. Rather than creating drawings, data is entered into a software, like Revit, database, and a complex query run to generate the drawing views. This approach, using data to drive the process, means you change something once, and as you can see in the video, every view updates. This leads to the concept of one version of the truth. It is this data set that other software solutions can then utilize. The same data is used to drive other downstream processes, such as virtual coordination, visualization, energy analysis, and estimating, etc. All these processes lead to reduced risk and improved quality. We are reusing the data in an iterative way rather than continually recreating the information. What is more, all the solutions are using the same data as the source of information to drive the process. In this data-driven rather than paper-driven process, the software solutions are the tools that the underlying data can run checks on. This helps ensure that the defined goals and uses, as shown in the previous slide, can be achieved. As the design team consultants use their design authoring software, in North America, typically Revit, they are building the foundation of the project dataset that will be used throughout the building lifecycle. With other software solutions using this dataset, the quality of the data is critical to enabling the BIM process to flow smoothly, and as such, compliance and auditing is required. The BIM process is comprised of 4 fundamental components. Policy. What are the specific requirements or proposed uses for the data and the specific data fields that are required by the owner and FM teams? Process and standards. Definition by the teams in the BIM execution plan, the BEP, of how they are going to achieve what has been asked for. Who is going to do what, when, where, i.e. in which model will the information reside, and how? What are the strategies to be used? Technology. What software solutions and versions are the teams going to be using? Data is very specific. Consider, for example, email addresses, where a period or hyphen changes who you might be sending something to. And people. The biggest challenge is change management. We all like to do things we're familiar with and know how to do. Change is hard, especially for those whose position is based on experience in the old process. Breaking down the 4 components of BIM further. So policy. It is the capital planning and facility management team's responsibility to define the BIM policy, the goals and uses for the data, typically specified in the BIM requirements specification. This is similar to how the owner team defines the facility program, setting out how the building is to perform and what is to be included. What, as an owner team, do you want the data to do for you during the design, construction, and operations lifecycle phase of the facility? What are the goals and uses? For example, space to be retained for maintenance and replacement. Design and construction teams would have to undertake virtual coordination to confirm this goal is met. Asset hierarchy. Parent-child relationships must be provided, requiring a specific data field or naming convention to be created and populated by the design consultants. Digital handover. All specified installed asset data, i.e. serial numbers, etc., and PDF documents, O&M manuals, must be provided and linked to design intent assets. The second component, process and standards. The design and construction teams review the BIM requirements specification, identifying what is required, and it is their responsibility to work out how and utilizing what software tools, processes, and strategies they are going to use to achieve it. This is all recorded in a living document, the BIM execution plan, which sets out who is going to do what, when, how, and where, i.e. in which model the information can be found. Management of the data and any duplication is critical. Auditing is required to ensure that the BIM execution plan is being followed and the data is fit for purpose. The third component is the technology, or the tools that the team will utilize. Different tools have different benefits and challenges. It is up to the design and construction team to choose the technology they want to use and ensure that it will meet the BIM requirements. BIM is built on the concept of collaboration, the sharing and reusing of data. The choice as to how this is managed and the tools they want to use needs to also consider visibility to the owner team. The owner team needs access for compliance during design and construction phases, as well as for the final handover. Finally, underlying all of the above is people. Change is hard, especially when one is under tight financial constraints or timelines. The older we are, the harder it becomes, especially if our position is based on experience in the paper process. According to Forbes, the most dangerous saying in any business is, "We've always done it this way." Meaning basically, whatever you say, this is what we're going to continue to do. The business world is full of examples where this approach has proven to be catastrophic. Compare, for example, the demise of Blockbuster set against the rise of Netflix. BIM is not a North American process. It is a global process. The AEC industry is highly inefficient and change is required. A BIM process is the way forward, and with the development of global standards, many countries have mandated the process for government projects or projects over a certain size. Finland, for example, has mandated that all building permits be submitted in an IFC, which is Industry Foundation Class, compliant format. IFC 4.3 being the current global data standard that allows the data to be read by any compliant piece of software. It is not a question of if, change is already happening and accelerating. The following statistics are pulled from the third annual BIM report, undertaken by the University of Toronto in 2020. The survey looked at a large cross-section of issues, the three highlighted here being the main issues related to challenges associated with implementing BIM. Firstly, industry resistance to change, individuals' lack of knowledge or skill, and from a business perspective, doubts on the return on investment. Also of interest in the survey is the fact that both users and non-users overwhelmingly agree that BIM is the future of the industry. As more and more owners start to require BIM on projects, your BIM experience will be a required component of any RFP, and those who have experience with the process will have the advantage. This is a case study from the University of California, San Francisco, UCSF Medical Center, a project where the BIM data and models were shared with Maximo, a CMMS system, or a computer maintenance management software solution. A leak occurred, impacting the cafe and threatening food services. The team were able to speedily locate the isolation valves through a 3D graphic and resolve the problem within a few hours, far faster than searching the traditional paper drawings and binders. Understanding asset locations saves time in resolving leaks and minimizing damage. This is a case study from a local project, the Royal Columbian Hospital, RCH Phase 1, with which we were involved. In this project, data and documents were collected relative to installed assets and tied to design intent assets before being exported to Maximo. Gustavo, a UBC PhD student, undertook a study and comparison with other projects and determined that 6 times more information was provided and that it was more accurate, complete, and accessible. In addition, the installed assets could be reached for maintenance and replacement. The required asset types and the installed asset parameters were defined in the BIM requirements, and QA/QC could be undertaken to ensure that all required information had been provided. A study was undertaken in 2017 by PricewaterhouseCoopers, PwC, looking at the life cycle impact, the return on investment, ROI, for the Department of Health Victoria Street refurbishment project. The study was undertaken in the UK, where Level 2 BIM became mandatory in 2016 for all public sector works. The project, a commercial office fit-out, estimated to cost around 22.5 million GB pounds, which is equivalent to about 38.3 million Canadian dollars, without BIM, achieved an overall saving of 3%. The report looked at the ROI from the perspective of benefits to the asset lifecycle, from following a BIM data-driven process using 2017 prices with a 13-year appraisal timeline. The figures quoted have been converted to Canadian dollars at today's exchange rate. As can be seen, benefits accrue at all stages, but the maximum benefit by far is to the operations phase of the facility. To round up what has been discussed and the benefits that can accrue to the different teams, improved collaboration means we are able to reuse work others have done rather than having to repeat it. The ability to see and move around the facility in 3D is hugely beneficial for coordination and visualization, as well as understanding the spatial nature of the facility. Reuse of the data, building on it iteratively throughout the life cycle. Cost savings through increased efficiency and reduced errors. Testing of the design for performance prior to construction. Spatial awareness supports those who are not familiar with reading and interpreting 2D information. Accountability, the ability to assign responsibility for scope and track completeness. The benefit of having one version of the truth rather than different versions on plans, sections, elevations, schedules, etc. As we move into the future and BIM becomes the norm, it is predicted that the data fields will have as much value as the geometry, with contract documents adjusting to include the model dataset as part, if not all, of the submission. This shift will require the normalization of the data so that all parties can access and use it in any software solution. This will require all model datasets to be in compliance with the industry global standard, which is currently IFC 4.3. So now let's consider BIM from the perspective of capital planning. First, a quick refresher from the first session, BIM 101. Remember, BIM is not software. It is a process comprised of policy, the goals and uses for the data, process, the strategies and workflows that the team will use to meet those goals and uses, and tools, the software chosen by the teams which they will use to achieve the goals and uses defined in the policy requirements. Finally, underlying all of the above is people and the support required to manage the change in process. BIM impacts the way in which projects are managed. If we look at the steps in more detail, the starting point is in generating a clear definition of the policy requirements, the goals and uses defined in BIM requirements specifications for the teams to follow. This step requires work effort from the capital facility teams. Once defined, the BIM requirements can be included in the project RFP and can be considered as part of the responses and contract language. It is the responsibility of the successful team to detail, within the BIM execution plan, how they plan to meet the defined goals and uses. The BEP records the strategies and workflows that will be used by the team. The team utilizes their preferred software tool to generate the design model datasets that in turn generate the 2D documentation. Auditing of this dataset is critical, as like a building's foundation, everything is built on top of it. Bad data leads to bad outcomes. At the end of the design phase, the project dataset is sufficiently robust to enable the generation of an asset registry. This is a list of all assets, rooms, or other information that is required for management of the project during its life cycle. During the construction phase, required installed asset information is linked to the design intent information, providing the facility team with the opportunity to start development of their preventative maintenance plans prior to handover. Update of the design model to reflect changes that occur during construction is a vital piece to ensure that the dataset provided to the owner contains not only accurate geometric information, but also accurate locational information and installed asset information. Fabrication models contain very accurate complex geometry, way more than required by facilities, but do not typically contain any design intent information. Why change? Other than agriculture, the AEC industry is the least digitized industry, whereas all other industries that have digitized are approximately 200% more efficient. The AEC industry is considered 30% less efficient than it was 30 years ago. It is estimated that transforming to using a digital process, i.e. using data rather than paper to drive the process, offers potential savings of around 25%. So what does that actually mean to you as an owner or project manager responsible for a project? The following 4 graphics show general statistics reflecting how the current paper-based design and construction process performs. Change orders on average add 10% or more to a project's budget. With regard to rework, it's estimated that approximately 30% of work undertaken on site is in fact redoing what has already been done incorrectly, with 25% of materials delivered to site ending up as waste. As to budget, it's estimated that 98% of all projects end up over budget for a variety of reasons. Perhaps unsurprisingly, a similar percentage also applies to delays or late delivery of projects. Added to these issues, the FMO team typically receives record drawings and binders months after completion, leaving owners trying to operate their facilities without the required information, leading to additional costs. All these issues lead to difficulty in finding required information. It's estimated that 30% of a facility maintenance and operations time is spent searching for the relevant, correct information needed to solve problems. The risks associated with the paper process that has led to the statistics previously described can be attributed to poor communication and collaboration. In the paper process, information is shared infrequently, and it is harder to check if the correct people have the correct updated information. In addition to this, historically, the industry has worked in silos, with information being shared only periodically. It also relies on the ability of an individual to interpret 2D drawings, and as the ambiguous visualization image shows, is it a duck or a rabbit? 2D drawings can easily be misinterpreted even by those used to reading them. 98% of projects experience delays, which can be caused by a number of factors: misinterpretation, incorrect construction that requires rework, incorrect or missing information, supply chain delivery issues, incorrect amounts delivered, weather or labor-related factors, or project funding issues. As mentioned, rework is estimated to account for 30% of construction costs. Resolving this one issue would have a significant impact on budget and delivery schedules. The graphic on the left shows the flow of information in the traditional paper-based workflow, whereas the one on the right shows the collaborative sharing and reusing of information within a common database environment, generating a single source of truth that BIM follows. In the data-driven workflow, everyone can access the required information rather than having to wait for a drawing view to be shared. The collaborative, data-based approach enables others to utilize current information within their design process, mitigating work effort and streamlining the design. Information can be shared frequently or, if preferred, be live. However, this collaborative approach requires management. The following are the top 6 high-level benefits from the perspective of capital planning, i.e. those paying for the project, that makes it worthwhile to transition to a BIM process. There is a reduction in risk through virtual coordination, visualization, and better access and management of the process. This in turn improves the quality of the final product, saves time through doing things once and then reusing them, supports enhanced collaboration between parties, improving efficiency along with the ability to reuse the data to support FMO throughout the life cycle of the project. However, BIM costs money. As an owner, you need to spend upfront to save through reduced risk, improved quality, retained space for access and maintenance, and to have confidence in an on-time and on-budget delivery, with a rich data set to support the life cycle, all provided at handover. The power of digital information is evident in the evolution of AI, this image having been generated by ChatGPT. In life cycle costing terms, the process is often considered as being broken down into 3 phases: design, accounting for 2%, construction, 18%, and maintenance and operations, 80%. Design includes internal and external consultants, financing costs, including site acquisition, and allowance for change orders. Construction involves the consultants as well as the trades and contractor, FF&E, financing, and change orders. Maintenance and operations includes custodial, grounds, waste facility management, utilities, renewal, and replacement, along with alterations and end of life. As can be seen, design time is cheap time, but it also has the most ability to impact all other phases. What, as an owner managing the project, are your responsibilities relative to a data-driven process? Primarily, you need to establish what the goals and uses for the data are, i.e. what do you want to be able to do with the digital information? A BIM requirement specification needs to be generated that identifies what these requirements are, articulates them clearly to the bidding teams so that they can be included in the RFP response. Ensure that when choosing the team, their BIM competency is considered as part of the selection criteria. BIM needs to be considered along with other criteria when selecting the teams. Participation in the digital process is critical. Teams need to understand that non-compliance is not an option. Management of the process with support from experts is required to ensure that processes are being followed and that the data quality is sufficient to meet the outcomes. BIM needs to be included in the business plan to ensure the correct allocation of funds, along with the required resources to initially support definition of the goals and uses, and to ensure that the digital process stays on track. The identify phase is defined as the time during which you, as an owner organization, work out what you want to achieve. What are your pain points, the existing gaps in your processes, and what are the BIM uses you want to target? Once identified, you can define the goals, uses, and expected deliverables. This requires the creation of a statement of goals and uses, definition of a standard and required deliverables for design, construction, and handover phases. Finally, there needs to be a realistic roadmap generated that defines the planned implementation of the BIM process on your projects. What are the short and long-term goals? Required resources? What is the implementation timeline? What criteria will define the implementation rollout? Is it new buildings, project size, project complexity, or project cost? When defining and identifying the goals and uses for your BIM requirements, you need to consider the end at the beginning and then work backwards to the start, layering on the different processes that you require the teams to follow. In a BIM process, the end informs the beginning, i.e., the tail wags the dog. The starting point is typically defining what uses are required for the life cycle phase, and therefore what data fields are required. Moving backwards to the start, establishing when during the process those data fields are required to be present within the dataset to drive other processes. The identify phase identifies not only why you are undertaking a BIM process, but also, by working with stakeholder groups, defines what the goals and uses for the data will be, along with a roadmap that will set out the implementation strategy for the organization. Once identified, a BIM requirements document can be developed, including defining the required processes that the teams are to follow, for example, virtual coordination, and when the data is required to be present in the model dataset to drive downstream uses. ISO 19650 provides a great framework to build the BIM requirements around. The BIM requirements need to be specific as to the required outcomes, the specific data points required during the design and construction phases, as well as those required for the entire life cycle, and what processes are to be undertaken. In addition, the data points required for a digital handover need to be clearly articulated, along with the process for generating a record model that correctly represents the built facility. As you move through the process from early design to IFC to construction to handover, each participant and group is contributing to building the dataset, so that by handover, a rich, robust dataset representing the facility has been accumulated and is ready for transfer to the FM teams. The next step, as the owner, that you need to appreciate is that the management aspect of a data-driven BIM process are different from a paper process. There needs to be a digital strategy for a project, defined in the RFP and BIM requirements, which aligns with the chosen contract form. To ensure that the underlying data is fit for purpose, an auditing process needs to be in place to check the data accuracy and consistency, the completeness and validity of the information. Data quality is critical, and issues are easier to resolve if they are found early. In addition, how accessible is the information? If the data cannot be accessed and used by the broader team, it loses value. Management of the compliance aspect of BIM is a challenge and requires consistency, flexibility, and collaboration. It is important to record what is working and what is not. A digital, data-driven process enables the generation of an asset registry, a list of all assets of interest to FMO, but typically focused on those assets that require maintenance. What is the installed asset information that is to be linked or connected to the design intent asset data? For example, serial number, warranty duration, warranty certificates, etc. At what point in time will the operations team be able to access the information to develop preventative maintenance plans? How will the quality and completeness of the provided information be checked? How and when will the data and document transfer to FM teams to support the life cycle occur? It should be no later than handover of the facility. To have confidence in the underlying data, it must be checked to ensure that it is accurate, valid, complete, timely, relevant, and consistent. Remember, BIM is about the underlying data and not about 3D. The data generates the 3D and the 2D drawing output, as well as enabling all downstream uses. Data is extracted so that other software solutions can use it to undertake virtual coordination, lighting analysis, estimating, etc. Poor data equals poor decisions. Quality data will drive the downstream goals and uses, as well as be future-proofed for the project lifecycle. During the management phase of a BIM process, it's vital that the owner has the required expertise on their team, whether an internal or external consultant. This is the entity that will undertake the quality control and will define the data checks to meet compliance. Does the team's BIM strategy work? Will the results meet what has been specified? Has the team recorded in the BEP how and who is going to do what to meet these requirements? Have the defined data points been established, understood, and the timeline for when the information will be present in the model dataset agreed? There is a need for both internal and external change management to support the evolution of a BIM process. The value in understanding a BIM process is that it addresses the main issues that currently plague the AEC industry. A BIM process will generate quality data, will provide access to others to use that data, will provide visualization to help better understand the project, reduce risk and improve quality, reduce change orders and rework, and provide an on-time and on-budget project, in addition to providing an accurate digital handover to support the entire life cycle of the project. As you embark on your BIM journey, here are some things to keep in mind. BIM is a relatively new digital process that impacts existing workflows within your organization. It is not just asking the teams to use a different piece of software. It impacts the entire capital delivery process. It is highly recommended that you engage a subject matter expert to help define and guide your identification of goals and uses, and to generate your BIM requirements specifications. Set priorities. Don't try to ask for and do everything at once on the first project. Less is more as you begin. Align your goals and uses to the industry maturity in your area and set realistic expectations. There is a learning curve. Consider carefully the contract type being proposed. Remember, to be successful, everyone is using and building on the data being generated in an iterative manner. BIM is a collaborative process, so it works best with a collaborative contract form, where the owner is actively involved. When choosing the team during the RFP, include BIM in the assessment criteria, along with attitude and BIM maturity. These things matter. Finally, it's vital to keep a lessons learned log and feed back into the initial BIM requirements. Now let's look at BIM from the perspective of facility management. The four main challenges facing facility teams at handover relate to post-construction defects, along with poor information and data fidelity, i.e. it's untrustworthy, not accurate or reliable. Auditing data during the process is critical to ensuring high-quality data for the facility management FM team. Associated with this is poor interoperability between the project data and the needs of facilities. Finally, a lack of consideration for the needs of the FM team early enough in the capital planning process to ensure that they get what they require. The current paper-based process results in several significant problems for the facilities team. Typically, handover information is provided months and months after the team has had to start operating the facility. They have had little to no opportunity to develop preventative maintenance plans ahead of handover. The record drawings do not reflect accurately what has in fact been constructed. To enter information into a CMMS, a computer maintenance management software solution, for example, the required data fields need to be sourced from the paper drawings and binders and then manually entered into the software. An error-prone process. Information not selected for the CMMS system resides in paper format, which is time-consuming to search and source information from. Perhaps one of the most challenging issues is related to being able to access equipment to undertake required maintenance or replacement. As shown earlier, this graphic depicts the relative costs of the different phases of a project's life cycle, from design and construction through to maintenance and operations and end of life. Now included in this graphic is the cost of people in undertaking the required work. Once their costs are built into the equations, then the balance shifts significantly. The purpose is to highlight in terms of life cycle costs where expending funds can have the greatest value and downstream benefit. It is worth noting that these figures are based on the traditional paper-based process. In essence, again, design time is cheap time, and it is here that the greatest downstream benefits can be achieved. High quality, rich design data is the foundation for associating installed asset information that is used for the life cycle of the facility. Virtual coordination provides the opportunity for the design and construction teams to ensure that sufficient space has been retained to enable maintenance and replacement of equipment. In addition, one can also check to ensure that sufficient space has been retained to enable physical access to overhead equipment. The ability to easily reach all required equipment, including shut-off valves, without having to shut down the facility is of huge importance to the maintenance team. In addition, understanding the exact location of all the assets has enormous benefits for speedily resolving issues. Within the digital process for handover, unlike the paper process, all relevant information is associated directly to the asset it relates to. The typical paper binder has types of information organized together, for example, warranty certificates, operations manuals, whereas in a digital process, each piece of relevant information is linked to the asset. Select the asset of interest and all required information is there at your fingertips. This leads to more efficient evaluation and processing of work orders. In this example, a saving of 10.6 man-hours per maintenance work order. In addition, the location of the asset is easily identified within the 3D space of the facility. In addition to having all information related to the relevant assets, sensors can be linked to room or space information to provide ongoing current data related to a variety of measures such as temperature, CO2, humidity, power usage, lighting, etc. This enables clear visualization of information regarding the building's performance. Finally, this same design information can be used to support room or space management. Usage of the space, the area, furniture, finishes, occupancy load, department, or any other useful information can be associated to the room or space to maximize the efficiency of how the building is being utilized. Color coding linked to occupancy software helps to further visualize how the building is being used and any spaces that are typically left vacant. As mentioned earlier, BIM definition, auditing, and data generation costs money. As a facilities team, you may be required to contribute to the capital cost, since you are the recipients of the greatest potential benefits. The digital data-driven process requires the team to spend upfront to save through reduced risk, improved quality, retain space for access and maintenance, and have confidence in an on-time and on-budget delivery, with a rich data set to support the life cycle, all provided at handover. When defining and identifying the goals and uses for your BIM requirements, as previously mentioned, you need to consider the end at the beginning and then work backwards to the start, layering on the different processes that you require the teams to follow. In a BIM process, the end informs the beginning. Again, the tail wags the dog. The starting point is typically what are the uses that are required for the life cycle phase, and therefore what data fields are required moving backwards to the start. What other processes and uses are to be layered onto the facility requirements, and when during the process are those data fields required to be present within the data set to drive those other processes. Firstly, do you understand your pain points? Using a prioritization process like the Moscow system, must have, should have, could have, and won't have, organize your issues and remove unnecessary items. Generating and collecting data takes time and costs money to audit and check, so it is important to focus on the must-have and should-have issues initially. Review what impact what you have asked for will have on the work effort for the design and construction teams. Ensure that your requirements are included in the RFP for the project. Asking for this information after award of contract typically significantly increases the cost. Make sure you include a lessons learned feedback loop in your process so that you continually refine and improve the process. All design teams have different naming conventions, so it is vital that a common classification system is chosen. It is important that as a facilities team, you define the classification system you wish to use. This underlying classification system acts as a common data structure for organizing the data set and supports data mapping. The typical choice is whatever is currently being used by the FM team and with which they are familiar. There are 3 potential classification systems: Omniclass, tables 13 and 23, Uniclass, which is the European system, and Uniformat. These 3 classification systems are asset-based and not performance-based as master format is. In addition to the classification system, define the acronyms that you wish to use so that the requirement can be embedded in the BIM specification. In addition, how granular do you need the information of the asset to be? The more granular, the higher the cost. Do you want to be able to extract the asset hierarchy, the parent-child information from the model dataset? If yes, what do you want it to look like? Again, how granular? How do you want to see the information? Included in a name or concatenated from different data fields? This needs to be embedded in the BIM requirements and is going to be provided by the design consultants and verified during construction. Clarity around how you want to see this information is critical to ensuring you get the results that are expected. Asset Information Requirements, AIR in the language of ISO 19650. You need to define what assets and what information, the data fields, are important to you during design, construction, and for facilities management. At Summit BIM, we have developed a Data and Geometry Specification, a DGS, combined with a Data Collection Specification, a DCS, that defines the assets, the use, the minimum required geometry, the required data fields, along with the time by which the information must be available in the model dataset to drive the defined uses. The specification links together classification system, name and number with acronym, required data fields in design, required geometric development on the submission timeline, and construction requirements. The organized nature of this specification provides an agreed and defined structure that can easily be audited against the model dataset to ensure that required information has been provided. Having considered assets, how about information you want or need related to rooms or spaces? Is it areas, department, designated use, or the finishes of walls, ceilings, floors, or installed furniture? What are you interested in, and where is the value in what you are asking to have collected? Like assets, rooms need to be organized around a classification system and the requirement clearly defined to avoid confusion and pushback. There is considerable talk around the topic of a digital twin. Many think it's an accurate geometric representation of the physical asset or facility. The focus and concept of a digital twin is that multiple different data sources can talk to each other to help better manage the facility. For example, linking flight arrival and departure software to the HVAC system so that the system responds to when gates are being used. There are many benefits for the FM team from following a data-driven digital process. The high-quality data can be used to drive multiple different processes during the life cycle. It will generate a preliminary asset registry at IFC, aligned with additional installed asset information that is to be provided during construction. This provides a clear understanding of what will be available at handover. Early access to this information supports development of the preventative maintenance plans during, not after construction. Visualization supports a clear understanding of asset locations and whether it is possible to access the equipment for maintenance. Virtual coordination not only supports ensuring space is retained, but also a reduction in change orders and rework. With data audits occurring during design, there is trust in the data fidelity that can then be exported into FM software solutions. To reap the full value of a BIM process, it's important that as an end user of the data, you're involved throughout the project. Ensure you understand why you and your team are doing this. Expect that there will be changes to your usual paper-driven process. Actively participate in the process and access the data as it is being generated to help familiarize yourself with the facility. The data set can provide insight into the project, along with data comparisons between submissions to highlight changes. During the management phase of a BIM process, it's vital that the FM team has the required expertise on their team, whether it be an internal or external consultant. This is the entity, the information manager, as defined in ISO 19650, that will undertake the quality control and will define the data checks to meet compliance. Does the team's BIM strategy work? Will the results meet what has been specified? Has the team recorded in the BEP how and who is going to do what to meet these requirements? Have the defined data points been agreed and understood, and a timeline for when they will be present in the model data set agreed? There is a need for both internal and external change management to support the evolution to a data-driven BIM process. The benefits of the digital process mean that at IFC, the dataset can provide a preliminary asset registry of all assets in the facility, along with the required installed asset information to be provided during construction. This preliminary asset registry provides an early understanding of what will require maintenance in the final facility. This required information is provided iteratively as the construction process proceeds, along with update of the design models to reflect changes during, not after construction, leading to a more accurate record model at handover. This preliminary asset registry also allows for data mapping to the end source software to be tested and the final data export structure to be worked out and checked during construction, so that when the data set is complete prior to handover, the data transfer can seamlessly occur. This is a short video demonstrating the data upload for installed asset information linked to design intent asset information. The cloud-based interface, BIM FMI, provides access for all approved parties and clearly identifies missing pieces of required information, as well as who has been assigned responsibility, so that follow-up can take place. The goal to collect required information that will support the development of preventative maintenance plans as soon as it becomes available. Typically, on approval of shop drawings, model and manufacturer become known and can be provided. Maintenance manuals can also be provided around the same time. It is most efficient if the subject matter expert, the trade, is assigned the responsibility for providing this information. Progressive collection of the information throughout construction supports the development of the preventative maintenance plans. As you continue your BIM journey, remember that although your needs start the process, you have to wait to get the data you require. It is vital that the data being generated is audited for quality, completeness, validity, etc. Adjust your high-value priorities based on feedback from design and construction. Align with industry maturity. It's important to stay real and ask for what matters and make sure you get it. Teams can be resistant and will look for loopholes to follow known rather than new processes. Keep your eye on the ball and monitor data upload to ensure you receive the information you need in a timely manner. Feedback is important to all parties. Since capital projects take years, feedback should be frequent so it can be influenced new projects about to start. Ensure that the teams are committed by having robust BIM requirements. and align with ISO 19650, which requires the draft BIM execution plan to be part of the RFP process. This ensures that the teams have considered how they would deliver on what has been specified. It is critical that internal business processes from design consultants or contractors do not stop the digital process from delivering on your needs. We have seen single entities bring the process to a halt. It is vital that the contract language and digital processes are sufficiently rigorous to be able to ensure compliance as the process moves forward through design and construction. From a lessons learned perspective, there are 5 key aspects that need to be considered. Change management of the people and the process, ensuring that funding has been made available to support this new digital process, ensuring that BIM requirements are precise and clear and that issues flagged during compliance audits are resolved. Finally, consider the contract type when asking for a BIM process. BIM is collaborative and requires sharing of models, datasets, and information. Implementing BIM from the designer's perspective. First of all, remember, BIM is a data-driven digital process that leverages digital technology, the software, to enhance a number of different aspects that benefit all parties involved in the AEC industry. However, if the benefits are to be achieved, it requires commitment and a willingness to change the processes, protocols, and strategies that were used in a paper-driven process. It is an evolution to a new way of working. It is not just a software purchase. So why should you as a design consultant be motivated to shift to a BIM process? To understand why it's worth the effort to undertake the change to a data-driven digital process, let's first consider the challenges with the existing paper process. Collaborating with other consultants through the periodic exchange of drawing views provide a whole slew of challenges. To name a few, correctly interpreting the 2D design intent, identifying system routing, sizes and slopes to mitigate coordination issues, constant flipping between drawing views to understand the information and the 3D nature of the issues. Lines do not contain information, whereas objects do. Version control, change management of the drawing views, the process of manually having to go through all drawings in a 2D process to make sure that all changes have been captured in all the various drawing views is error-prone, time-consuming, and highly inefficient. The challenges in correctly updating changes across drawing sets is difficult in the best of circumstances, but more than challenging when changes are being made late in the design process and under time pressures. This same challenge of all drawing views being disconnected from one another leads to difficulties with managing coordination, leading to a high risk of errors and mistakes. It is a common occurrence for an RFI to question which drawing view they should be following: plan, section, elevation, or schedule. Representing a 3D facility only through 2D documentation is problematic, especially with complex geometry. Does the 2D drawing correctly represent the 3D reality? The manual process of managing and updating all the separate drawing views to ensure that changes made to one have been captured in all leads to poor documentation, inaccurate costing, and increased change orders. It's time to recognise the limitations of this traditional process and explore opportunities for improvement. We need to transition to a digital, data-driven solution that offers greater efficiency, transparency, and sustainability. Transitioning to a digital process isn't just a preference, it is these days a strategic necessity. One risk associated with the paper process is data and knowledge loss, as information is shared infrequently or not recorded at all. Working in silos causes disconnection, leading to quality issues, human errors, and increased costs. Remember, 98% of projects experience delays, with rework estimated to be responsible for 30% of time on site. You can see how resolving even a few of these issues would significantly impact budget and delivery schedules. The solution to this problem is switching to a data-driven digital process. The use of database software solutions generates the concept of one version of the truth and supports the sharing and reusing of information, which is key in driving the process forward. Moving an organization from a paper-based to a new digital process is a top-down approach, which takes time and requires support. BIM needs to be embraced by the top management and from there filter down to the rest of the employees. It is the goals that drive the uses for the data. These are some of the most common goals and the associated uses for design consultants. So improved collaboration reduces the RFIs and the change orders. Efficient design process, less time redoing work and updating changes. Data-driven decision-making, harness the inherent data to help make decisions. Sustainability, assess and test the viability of various sustainability options. And visualization enables all parties to understand your design concept and vision. Remember, the goals must be driven, strategic, and embraced by the company leaders. Top down, bottom up doesn't work. It's important to set goals and explore the many ways in which a data-driven digital process can benefit design consultants. By fully embracing BIM, we can improve our design processes, work better together, and achieve great results for our clients. Be smart when defining your goals. This is an acronym that stands for specific, measurable, achievable, realistic, and timely. Short-term goals for design consultants using BIM often focus on making immediate improvements in efficiency, communication, and project outcomes. By concentrating on these short-term goals, design consultants can swiftly reap the benefits of a BIM process in terms of efficiency, collaboration, and project quality, setting the foundation for long-term success with BIM integration into the company. The typical long-term goals for design consultants go beyond immediate efficiency gains and concentrate on strategic objectives that foster organizational growth and sustainability, such as establishing internal BIM standards and workflows, integrating BIM into the business operations, strategic development and expansion of internal BIM skill sets and capabilities, and enhanced collaboration and integration. We need to consider BIM from both an internal and external perspective. So what do we mean by that? The internal is how it will benefit your business, and the external is meeting the requirements that will benefit your client's business. As mentioned, these goals and objectives must be fully embraced by the top management to make sure they will be accomplished. The designer's internal role is related to benefits for your business, rather than external benefits for your clients. It is focused on establishing your internal business goals and objectives. The established goals and objectives will define the business's internal BIM standards and protocols. Allocation of resources, this is both financial and human, and involves building team skills, roles, and the purchase of hardware, software, required infrastructure, and libraries. Awareness of the risks associated with implementing BIM. Create strategies to mitigate them. Finally, ensure that your teams have the required support and guidance during the transition. Now let's consider what happens when we build on the external role, the potential goals and uses your clients want. Your team needs to understand the owner's goals and uses for the underlying data. BIM is all about collaboration with other disciplines and stakeholders. As designers, you need to define strategies and workflows that achieve the owner's goals, which may differ from your own. There is a need to document the processes and strategies used and to manage audits and provide feedback. Developing a roadmap takes time and involves setting out the required steps and generating a clear path to follow. A BIM roadmap is a structured plan that supports the implementation of a BIM process within the organization, a step-by-step guide. So identify the pain points and the inefficiencies. Define specific goals and objectives. Focus on goals that are both important and achievable. Establish the timelines. Allocate resources. What do I need? When do I need it? Who can provide it? Develop strategies to support the achievement of the goals during the implementation phase. Document lessons learned so that you can have a feedback loop that will enhance the next project. It's important to stay flexible. Your BIM standards should be adaptable and able to accommodate your client's goals and uses, which will vary on a project-by-project basis. Remember, don't pursue BIM solely for internal purposes. From an external perspective, understanding the owner's specifications. These are the BIM requirements on a project set by the owner to establish their specific goals and uses for the data. In ISO 19650 language, the organization's information requirements, the OIR, and the project information requirements, the PIR. This document establishes what it is the owner requires from the process. It is the design and construction teams who determine how they are going to achieve what has been asked for. The data and geometry specification is part of the BIM requirements and specifies the asset information requirements, the AIR in the ISO 19650 language. It specifies those assets that the owner requires from a lifecycle perspective and what data and design consultants need to associate to them. This list is just a sample. The list impacts all disciplines and is normally built around a classification system, either Omniclass, Uniformat, or Uniclass. It provides a clear definition of what is required. This portion of the DGS, the data and geometry specification, identifies the expected level of geometric development and the project phase by which the information is expected to be available within the model dataset to drive other downstream uses. This information, along with installed asset information, forms the basis of the Asset Information Model, the AIM, in ISO 19650 language. The BIM execution plan is the project document where the design team records their proposed strategies and workflows that they will use to achieve the goals established in the BIM requirements by the owner. The design team is responsible for defining who is going to do what, when, and how to achieve the specified goals. What are the workflows and protocols that are going to be used? Which team is going to be responsible for what data and modelling requirements? And when will the information be available? What is the timeline? Things to keep in mind when generating a BIM execution plan include the fundamental project information. Remember, the BEP is going to be used as the basis for model and data audits. It is a living document that will need to be updated during the project, and that the final BEP is a record document for the project. This graph is known as the McLeamy curve and was generated by Patrick McLeamy of HOK. It highlights how, in a BIM process, the work effort is shifted forward, reducing the cost and the risk compared to the traditional paper process. In the traditional paper process, the bulk of the work effort, shown in red, falls outside the curves of ability to control cost and the cost of design changes, whereas the BIM workflow, in green, it falls below the curves. These are some of the benefits consultants enjoy after adopting BIM. You have better collaboration. It ensures consistent design across different disciplines. smoother design changes, improved visualization, which facilitates efficient design iterations. You have less errors and rework, the early identification of conflicts during design due to virtual coordination, leading to fewer mistakes. You have simplified documentation. The automation of views and schedules streamlines the documentation process. You have improved client communication, where renders and 3D walkthroughs effectively communicate design intentions to clients. You have enhanced efficiency and productivity, where repetitive tasks are automated, boosting overall efficiency and productivity. Through the use of advanced visualization and generative design, consultants can assess various design options in a virtual space, utilizing computing power to test multiple iterations to optimize the design. By implementing BIM during the design stage, designers can incorporate sustainability principles. This includes performing energy analysis to evaluate and enhance building energy performance early on in design, resulting in more sustainable and energy efficient design solutions. Additionally, designers can conduct lighting analysis to assess lighting conditions, optimize lighting strategies, and improve occupant comfort and energy efficiency in buildings. This helps in optimizing energy performance and environmental impact throughout the building life cycle. BIM is a data-driven process, with designers using database software tools, where the creation of drawings, schedules, and specifications is a query on the dataset, saving time and ensuring accuracy in documentation. When a change is made, in any view, all associated sheet views automatically update, i.e. change a door size and location, and the door schedule, floor plans, sections, and elevations will all update. In addition, designers can implement standardized templates, libraries, and design guidelines to enhance efficiency and consistency across all their projects. One of the most powerful aspects of this new process is through visualization to support communication. The ability to utilize 3D modeling to make immersive visuals and renderings explaining designs to clients, stakeholders, and teams. They can also use virtual and augmented reality for interactive design reviews and presentations. For example, showing the sun shadow path throughout the day. Design consultants can track project progress by visualizing project data using various dashboards and graphs. This helps achieve consistency in data across projects and enables automated area statistics and data quality checks. However, to reap the benefits of BIM, design consultants must overcome certain challenges. BIM introduces new roles that need to be established within the organization. It demands a different skill set and expertise compared to traditional design methods. Design consultants may require in-depth training to become proficient in BIM process and workflows. Closing the knowledge gap is crucial for successful implementation. It's important not to mix up BIM roles with software proficiency. Some roles, like the information manager, may not be readily available within the organization due to the specialized nature of the role. In such cases, external consultants can be considered. The biggest challenge is people's resistance to change. Change is tough, especially when finances or deadlines are tight. As we get older, it becomes even harder, especially if our expertise lies in traditional methods. Forbes warns against the dangerous mindset of "we've always done it this way," which essentially shuts down any discussion of change. Managing change requires clear communication, engagement strategies, managing expectations, ongoing support, and fostering a culture of collaboration and information sharing. Design consultants encounter various challenges with BIM. initial investment and training costs, i.e. the software, dealing with interoperability issues among different software platforms, adjusting to new software workflows and learning curves, resource constraints like ensuring adequate training and skill development, potential legal or contractual implications, as most contracts are still based around the paper process, data security concerns such as protecting sensitive project information. These are the 6 most common lessons learned when working with BIM in the design phase. Change management. People are often resistant to change, so it's crucial to plan ahead and set clear expectations. No plan for management of the data. Unrealistic expectations from upper management. Assigning roles based on software skills without understanding that BIM is a process enabled by software. Understanding the difference between BIM expertise and software expertise is crucial for success. Finally, appreciating where a digital process and paper process deliverables differ. Despite the challenges, it's important to note from a report by Toronto University that both users and non-users of BIM overwhelmingly agree that BIM is the future of the industry. As more owners demand BIM on projects, experience with the process will become a crucial advantage during RFP selection. To sum up, continuous improvement. BIM is an ongoing process. Its strategy is not fixed and evolves based on lessons learned and industry advancements. Long-term value realizations. The true value of BIM unfolds over time. BIM processes gather valuable data and insights, ensuring maximum benefits on each project. A well-structured roadmap and timeline are essential for guiding BIM implementation, aligning it with organizational goals. A commitment to delivering top-quality projects ensures competitiveness and innovation. Learning from past projects helps develop efficient change management strategies for future projects. BIM represents a shift to collaborative, data-driven methods, going beyond 3D modeling to integrate valuable project data. So let's move on now to BIM from the perspective of the contractors and the subtrades. Why should this section of the AEC industry consider shifting to a BIM process? It's simple. Embracing BIM brings greater efficiency and value to projects, leading to better outcomes for clients. Projects are becoming increasingly complex. To keep up, we need to calculate costs and labor more efficiently. With tighter timelines and budget constraints, efficiency is key. Sustainability in construction is more important than ever, and BIM plays a crucial role. BIM facilitates prefabrication and streamlines the construction process. Overall, BIM enhances project outcomes and supports the entire life cycle of a building. The biggest motivation of all, the BIM process can be measured, audited, and compared to other projects. This lets you identify what worked, what didn't, and how to improve for your next project. It's vital to recognize and tackle the challenges linked with traditional paper-based processes. For example, limited collaboration, hard to see issues and conflicts when viewing 2D drawings, managing change orders, issues found and resolved during construction are costlier and create delays. Value engineering. The ability to assess various design options is far more time-consuming and difficult to manage. Disorganized deliverables, resulting in confusion, delays, and inefficiencies on site during construction. Failing to meet the owner's objectives to provide accurate data at handover. And data disconnected from drawings. We must shift to digital, data-driven solutions that provide better efficiency, transparency, and sustainability. As I mentioned earlier, during design, transitioning to digital processes isn't just a choice, but a strategic necessity now. These are some of the risks associated with the paper process: the disconnected workflows, poor communication and collaboration among stakeholders, limited consideration of lifecycle requirements, inaccessible or inaccurate data, lack of risk management. Addressing even a few of these issues will make the process more effective, resulting in cost reductions and improved project outcomes. The graphic on the left, as shown before, illustrates the flow of information in the traditional paper-based workflow, while the one on the right demonstrates collaborative sharing and reusing of information within a common database environment, a CDE. In the data-driven workflow, everyone can access necessary information from a trusted source, eliminating the need to wait for a drawing view to be shared. The use of a CDE supports the collection and analysis of project-related data, enables data insights to optimize workflows and resource allocation, integrates data-driven technologies and tools. The goals and uses may vary from design to construction, but the implementation process stays consistent. Goals should be set, strategized, and embraced by top leaders in the company. This commitment needs to trickle down from top management to the bottom. The reverse approach doesn't yield the same results. As we delve deeper into BIM, it's crucial to pinpoint potential goals and explore the wide array of uses that BIM offers for GCs and subcontractors. So remember SMART when defining your goals: specific, measurable, achievable, realistic, and timely. The short-term goals for general contractors and trades using BIM usually aim for immediate improvement in efficiency, coordination, and project delivery. By prioritizing these short-term goals, general contractors and trades can swiftly experience the advantages of BIM, including enhanced coordination, collaboration, efficiency, and project delivery. This lays the groundwork for long-term success in implementing BIM within their organization. Long-term goals for general contractors and trades using BIM typically includes broader strategic objectives aimed at maximizing efficiency, improving project outcomes, and enhancing competitiveness in the construction industry. By aiming for these long-term goals, general contractors and trades can unlock the full potential of BIM to promote operational excellence, stimulate innovation, and attain sustainable growth and success in the construction industry. Looking first at the internal role, i.e. the benefits for the organization, moving to a digital process is most successful when it is top-down evolution driven by management. Defining what issues are going to be tackled first, establishing what the company goals and objectives are, i.e. the internal uses for the data. Once the goals and uses are defined, then the internal BIM standards and protocols can be established and resources allocated. Be aware of risks and focus on creating strategies to mitigate them. Ensure you have access to guidance and support for the teams throughout the process. The external role, i.e. what are clients likely to ask from you from a BIM perspective? Understand the goals and uses that the owner has for the data and the role that the GC and trades will have to play in meeting them. Communicate and collaborate with other stakeholders. BIM is a team sport. Devise strategies to fulfill the owner's goals that may differ from their own. Document in the BEP the processes and strategies to be used. Be aware that one of the primary goals of high importance for owners is the handover material required to support the life cycle. Management of the data collection process and digital deliverables is critical. The BIM roadmap is a structured plan that helps implement BIM within the organization, a step-by-step plan. So as with design, identify pain points and inefficiencies, define specific goals and objectives, focus on goals that are both important and achievable, define the timelines, allocate your resources. What do I need? When do I need it? Who can provide it? Develop strategies to achieve goals during the implementation phase. Document lessons learned so that you can have a feedback loop that will enhance the next project. Both design and construction phases have to comply with the owner's needs, the external role for the construction teams. Understanding the owner's specification and how that's going to impact your scope of work, along with the impact on your internal BIM process, is critical. BIM requirements vary on a project-by-project basis. They are set by the owner and specifically address the owner's goals and uses for the data. They are typically mandatory, so be aware of both internal and external BIM processes will help in ensuring your success and preventing rework of internal standards on projects. Of critical importance for owners from a life cycle perspective is the handover information. Working in a digital process involves the collection of data and documents which will be linked and associated to the instance of the asset they relate to. This section of the data collection spreadsheet displays the data fields required for each asset type during the construction phase of the project. It includes warranty certificates, serial numbers, models, manufacturer, etc. To support the development of preventative maintenance plans, information needs to be uploaded systematically. So, i.e., on approval of shop drawings, model and manufacturer of an asset can be provided, along with the operations manual. These are key fields required for development of preventative maintenance plans. This information is crucial for the building's maintenance and varies from project to project. Remember, the BIM execution plan is the document where the construction team proposes their strategies and workflows to achieve the goals established in the BIM requirements by the owner, as well as their own internal goals. How will you achieve the goals and uses? What are the workflows, protocols, etc.? Who is going to be responsible for what? i.e., what as a GC will you undertake and what will each trade be responsible for? How will you manage and coordinate? What process is the data to drive? Scheduling, construction phasing, sequencing, virtual coordination, clash detection, prefabrication, resolution of issues, model updates, and coordination with subcontractors and construction teams. When do you require the information needed to drive the defined uses? Some things to keep in mind. Don't forget to include the base project information. Compliance checks, audits for data and document collection as a handover deliverable will be using the BEP as the basis for compliance. The BEP is a dynamic document that will change as the project proceeds. It's important that it is regularly updated for future reference. And don't forget, the BEP forms part of the handover deliverable. What are some benefits for the general contractor and the subcontractors? Of significant importance is the concept of one version of the truth, a single source of information, easy access to information in a common data environment, providing easy search, sort, and filter of information that all stakeholders can refer to for accurate and up-to-date material. The ability to bring multiple models together, to undertake pre-planning and virtual coordination to check that all the pieces will fit, is of huge importance, as it mitigates risk and reduces rework and delays on site. Collaboration among the various stakeholders is key in benefiting from this process, as it enables resolution of conflicts between the various building systems, for instance, structural, mechanical, or electrical, while the information is still digital. Using a common data environment allows for sharing information and making decisions collaboratively. both internally and externally with clients, design consultants, and subcontractors. Aligned with virtual coordination is the power of being able to visualize all the myriad components that comprise a facility in a 3D environment, utilizing color to help identify different assets and systems, far clearer than a 2D black and white drawing. This process offers realistic 3D visualizations of the project, enabling all the various stakeholders to clearly picture the design and identify potential conflicts and issues. In addition, this maximizes the efficiency of the installation process through integrated scheduling that demonstrates clearly the installation sequence, as well as identifying maintenance access challenges all before construction starts. BIM has the ability to be utilized to support the development of an accurate cost estimate and material quantity takeoff, which supports labor estimates for the project. This data can also link with scheduling data to support progress payments. Cost data can be included into the model dataset to help understand the project's total cost more effectively. With BIM, costs can be automatically calculated based on material, labor, and other resources associated with the model elements. This saves time, optimizes resource allocation, and reduces cost overruns. 4D or scheduling and construction simulation provides enhanced construction planning, which involves simulating the construction process to help contractors identify conflicts and allocate resources efficiently on site. It integrates scheduling information into the model, enabling all parties to visualize the construction sequence and plan more effectively for which trade will be working where and when. This method is also useful for detecting scheduling issues and overlaps. According to an Autodesk report, as can be seen in the graphic, contractors experience 4 key benefits at a high or very high level. Accurate scheduling also supports the concept of on-time delivery, where product is brought to site, stacked on the truck in the correct sequence, and installed without being stored on site. BIM facilitates a more efficient prefabrication process by empowering off-site construction methods and prefabricating components using digital models. This process leaves the construction site clear for those that must be there. Prefabrication increases the quality and reduces the install time on site. This streamlines the construction process, taking it a step further into an industrialized approach and promotes waste reduction. BIM enables the creation of accurate and complete documentation where installed asset information, data, and documents are associated to the model object. Information required to support development of preventative maintenance is available during construction, with the entire project dataset available at handover. This provides owners with all the necessary information required to improve management of the facility throughout the project lifecycle. This adds significant value for the client. The construction sector's contribution to global warming ranges from 39% to 50%. With the climate crisis, sustainability is becoming increasingly important in construction projects. By integrating sustainable practices into BIM workflows for energy analysis, material optimization, and waste reduction, the environmental impact can be minimized. As sustainability expectations grow in the industry, construction firms need to demonstrate expertise and strategies to stay competitive. Nearly 70% of survey participants, shown in the graph, expect BIM to have medium-level impact on sustainability and resilience in the next 2 years. BIM can simulate construction process in a virtual environment to assess worker safety on-site, as well as clearly highlight the specific dangers. With the right data, BIM can streamline the implementation of safety measures to reduce incidents. Health and safety are always crucial in construction. Firms with strong BIM practices in place are better equipped to manage these challenges effectively and efficiently. This survey from the Autodesk Dodge Report white paper in 2022 rates BIM benefits: reduced number of man-hours on site, improved safety awareness, reduced environmental impact, reduced incident frequency rate, and reduced insurance premiums. In terms of growing the business, in addition to broadening the services contractors can offer to clients, BIM brings sustainable business growth and bidding advantages. From the same 2022 survey, the following 4 key benefits are notable: improved stakeholder engagement, higher percentage of successful projects, increased bid efficiency, and improved BIM win rate. These statistics, also from Autodesk Dodge Construction Report, are from the perspective of general contractors and specialty subcontractors. BIM is attributed as being a significant and positive impact on project cost and quality, from reducing on-site issues to optimizing work during construction. Once again, the biggest challenge in transforming any organization from a paper to a data-driven process is the people. People do not like change. Single individuals can derail a project, so team selection is critical. Remember, BIM is a step-by-step process. It requires a paradigm shift in how we have previously worked in the AEC industry. And to succeed, one needs to follow a specific process. The required change to enable a data-driven digital process impacts the entire industry, from contractors to sharing of information and involvement of fabrication during design to the final handover of information. We need to create a new mindset to allow new results. These are the most common lessons learned which are observed when transitioning to a BIM process during the construction phase. Change management. As mentioned, people are most complex aspect, and a single individual can upset the apple cart. Technology adoption and the skill gap pose challenges which can be addressed. Understanding that BIM is a process, not just software, and hire people accordingly. Ensuring the quality of construction data requires management. There is sometimes resistance to sharing this data. Dealing with the challenge of legacy paper-based process and deliverables identified in contracts. Something important to remember is that despite the challenges of BIM adoption, its usage is growing in the construction sector. BIM is not just a passing trend. Of those contractors that have adopted a BIM process, 81% are using a common data environment to host project information. 32% of construction firms, up from 17%, are expecting to use BIM on 75% or more of their projects. Over the last 5 years, the BIM adoption has risen considerably, with its adoption anticipated to accelerate. The use of a common data environment is noted as being very important to supporting achievement of the benefits. Increased adoption and expanded usage of BIM are anticipated in the near future. All industry sectors report a positive perceived ROI from BIM investments, with increasing returns as their BIM maturity advances with each project. Construction professionals report a perceived 74% ROI, with general contractors reporting a 24 to 49% perceived benefit, trades a 10 to 24% benefit. Reduced rework, 64%, improved schedule control, 51%, and improved win rate, 52%, as a perceived ROI. To sum up, BIM is not just a passing trend. It's here to stay. The question isn't if you should adopt BIM, but when. From virtual design and construction to integrated project delivery, BIM revolutionizes project delivery methods. This leads to reduced rework, improved coordination, and accelerated construction timelines. Proficiency in BIM not only sets you apart from competitors, but also enhances your ability to win bids and secure prestigious projects. This includes higher quality construction, cost savings, and faster project completion. BIM enables teams to work together more effectively, resulting in smoother project workflows and better outcomes. By delivering projects that meet or exceed expectations in terms of quality, cost, and schedule. By embracing a growth mindset and change, we position ourselves for long-term success and continued innovation in an increasingly competitive market. So thank you for watching this video, and if you have any questions, please do reach out to BC Housing.